So hello guys, today we will work with calculating cost along network. In the previous tutorials we have worked with fire stations using this measuring the straight line distance such as Euclidean distance from the analysis location points. But the problem with this method is that sometimes there are places where the streets do not go, such as across the lakes or other natural barriers. So network analysis tools allow you to overcome some of these difficulties by performing distance analysis along the network. So networks can include streets, pipelines, electric lines, train tracks, etc. These networks all have the connectivity and something traverses them. So for instance, we have a cost per mile for each street segment. The network analysis extension can show how far we can go for $1. So for this tutorial we will calculate the time that takes to traverse each segment and see how far we can go in a specific number of minutes. So we will use this network analysis extension to show how far the fire trucks can go in a given amount of time. So we have this network GDB, network analysis, fire stations and street center lines. These are a location of my fire stations. Here these are my street center lines. So first let's go to the properties of street center lines tool and go to the field section. We can see here the minutes. We will use this attribute. So let's create a network, new network dataset. Let's call it fire drive time, street center lines. Do you want to run this network? So next. Here is specifies the attributes for the network dataset. So minutes here, impedance minutes, time attributes minutes. Let's create next. The network dataset has been created. Would you like to build it now? Yes. Let's build it. Do you also want to add all the feature classes that participate in fire drive? No. So you can see this fire drive time created, and fire drive time junctions also have been created. So let's go to the street center lines. This is my minutes. So I have this attribute. How I calculated minutes. Let's go to field calculator. So there's a shape lengths of each street, and I divide it into I have here also speed limit, and I need to multiply it to 50 to 80 and divided to 60. So this is how it will compute minutes, which with maximum speed can cross a fire engine within this street. Sometimes it's mostly less than a minute. Sometimes it's slightly more than a minute for a longer streets, such as this one. It will take almost 2 minutes. So and let's activate network analysis here. This is one network analysis, and we need new service area. So far it's empty, but it's added. So new network will allow us to perform several types of network analysis, including routing, finding the nearest facility, creating an origin destination cost matrix, etc. And now we will use this tool called add locations. You can type it here, add locations. Service area here will be supply facilities, and we need this here, fire stations. So add location tool will move even though we have the fire stations as a feature class in our map, they must be matched up with the network database that we created. So this tool, add location tool, will move them into the framework of the network so that they can be used in the analysis. So fill this station num. Here is snap option. It's okay. So as we can see here, zooming, so this new locations have been added. So let's go to the properties of service area, and we need this analysis settings. We need to put here 1 minute. You can change it to your time. So this impedance 1 minute. So attribute is 1 minute, and we have impedance minutes. So this ArcGIS recognizes the keyword as a valid field name. And when we create fixed minute, we need to click here solve button, and we can see here this areas, polygons here, showing the service areas for each station. So for the first, second, and third station, notice also that they are not so nice rounded buffers that we got before using this multiple buffer or Euclidean distance tools, because it's a good example of the difference between straight line distance and the distance along the network. So just computing these buffers gives us the straight line access in minutes, where this fire engine can get from one location to another one. But when it comes to real life situation, we have this network of streets. For instance, this is a fire station, and within 1 minute, this fire engine from this fire station can get to this within this area of locations, because these networks are complicated. So we can export this thing, but we can export it as a separate polygon. Let's go to the symbology. So we can change the colors as well. See, for each fire station, this is the fire station. Can close this one. So this is fire station 551. This is fire station 553, and yes, we can. Yeah, we can just click to the top, and this is fire station. Or we can go to this polygon, see the fire station polygons have been highlighted. This is fire station 551. This is the first fire station, the 553, 500. So this complex networks allow us to analyze real data, how the fire engine from certain fire station can get to within 1 minute. So taking into account this complicated street center lines network.